Good morning, guys. Today we're going to talk about Tesla cars and why they are the best cars in the market. We're going to go through all their features and explain why their features are better than other cars. So let's first talk about their HVAC system. Their air conditioning system is much better than other cars because it goes from left to right and doesn't have any moving parts. It has two streams of air, one going up and one moving forward, and depending on the force, it can direct the air towards any place. So you can control the airstream directly from software, and that software will control the speed and the force of both going up and moving straight, so it can direct the air towards you where you want. The second part of the air conditioning system that makes it much better is that it contains only one cooling bottle that's called a super bottle. Usually, most cars have two cooling systems, one for the motor and one for inside the car. And the reason for that is that most companies have an engineering team and design team that are separate for each department. And because Tesla has an integrated approach, they can have one super bottle that makes the car cheaper to produce, and that's one reason that Teslas are better. Another feature that you can actually see that Tesla has that other premium cars also have is that their wipers are automatically enabled whenever there is rain. But unlikely most premium sedans, they don't have a rain sensor. They actually activate through their cameras. So they have a neural net that detects whenever there is rain, they can actually start the wipers. And depending on how much rain there is, they can actually increase or decrease the speed. And that's all done by software and their cameras detecting if there is rain or not. Because their wipers just use a camera, it's much cheaper to produce that than having a different rain sensor. Tesla Model 3, as you can see, has the best electric motor in the market. It weighs the least and has the most power. Model 3 weighs around 48 kilograms compared to Chevy Bolt and BMW i3 that weigh around 50 kilograms. And it has 40% more power compared to its competitors. Tesla can produce a motor that weighs less and is more powerful because it uses magnets in a certain configuration, creating something called the Hallback array. And the Hallback array is just the way the magnets are positioned, as you can see in this configuration, and it generates a magnetic field that's much stronger for the motor to move. Not only its motor is much powerful than its competitors, its battery and powertrain are integrated and they were designed as one central piece, as you can see in this video.
Now, Tesla's using kind of a clean sheet approach, but something that looks like it'll be much more conducive to be mass produced. It's also rear motor, rear drive. All the electronics that handle, for managing voltages and all the other stuff is in a box right in front of the rear motor. So all your weight and everything is kind of low and down at the rear. And then the entire floor is battery pack. And they actually end up with a lot of room up front. They've done a lot of really tight integration of everything. So the packaging and space utilization of this is pretty fantastic.
Yeah, it is.
A good sized trunk up front, all of the area in the middle for people and cargo, and then a good sized trunk in the back. It's a very efficient packaging solution.
Its battery plus powertrain costs around $12,000 compared to its competitors that cost around $16,000. Its battery powertrain uses around 4,416 batteries of 211 times 70 lithium-ion batteries, and the cost per kilowatt hour of its batteries is the best in the market. Whenever you're doubling the output of some product, the costs go down around 18%, and we have seen that Ritz's law holds true for batteries and electric cars and other things like that. Its battery and powertrain are integrated, and they were created in such a way that there are aluminum strudel channels that go through the the battery so that it can cool it down whenever you're driving it around. Not only that, Tesla is developing its own batteries and recently bought a company called Maxwell Technologies. And Maxwell Technologies has been developing a new technology to create dry battery electrode. What that means is that it doesn't use any liquid solvents. The new batteries are much more dense and they can hold around 500 watts per kilogram compared to 250 watts per kilogram. Right now, batteries for Tesla can drive around 350,000 miles because it wears out as you recharge it. And the new technology that Tesla is going to announce can recharge for 1,000,000 miles. When Tesla engineers developed the new suspension, they base the technology and they created a suspension based on NASA research. The frequency that the suspension moves is the same as when you walk around and jog around, and that research stated that that's what humans feel comfortable for a long time. Tesla brakes were developed in such a way that it has 4-pot calipers and it makes it a much safer drive. It can slow down much faster than other cars. Because their cars are much more heavy, because they have the weight of the battery, Tesla engineers had to design their wheels with much more stiffness so it can have a cornering grip. Not only that, Tesla engineers added foam inside the tires so that there's not as much sound or noise coming out inside your car. Teslas are also the safest cars in the market. They have the lowest probability of injury, and it has a bunch of components that makes it the safest car. So the weight distribution is around 50-50 in the front and in the back. Not only that, it has a low gravity center, and depending on where the car hits, it's protected. So because in the front, Tesla is much more safe than other cars, and when sitting in the front, it has the frunk that it's basically the trunk but in the front, and that prevents that the force from the hit goes to the driver or the passengers. Compared to other cars that have a motor in the front, imagine if you had a rock in front of your car and something hits that rock will hit you. Instead of that, Tesla has just air that serves as a natural airbag that protects you from crashes. And it has a super strong aluminum beam in front of it. It prevents it from hitting you. And it has structures all over the car, on the sides, on top of it, that prevent it to hit passengers and the driver. Let's talk about its system. So Tesla has chargers everywhere and it has the best technology out there. It's in its 3rd generation of Tesla Superchargers that can charge around 250 kilowatt of power. And it has Tesla is in its 3rd generation of Superchargers that can deliver up to 250 kilowatts of power, and that can make Tesla cars charge up much faster than other cars. Also, its software tells the car to cool down a little bit before you go to charge so it can charge faster than other cars. Tesla also has the best self-driving system out there. Tesla has designed its own hardware for its self-driving system. It has designed its own neural network that's actually 20 times, and Tesla hardware is much better at processing its neural network, so it can actually process 21 times more frames per second compared to its latest generation. And not only that, it's much more efficient. It uses much less power compared to its old system. And it costs around 20% less than its predecessor. And according to research by Arc Invest, it's 4 years ahead of competition, NVIDIA in this case. Not only that, Tesla has a fleet of cars running its software that captures moments here and there and is running its software all the time and capturing data, which makes it much better than its competition. It has around almost 1 million cars driving around just capturing data, so it can drive better. And that amounts for around 3 billion miles driven with its system. Compared to competition, it's 4 years ahead. For neural networks, data is the most important part of it, and Tesla is years ahead because it can capture so much data from its cars running around. And because Tesla cars are driving around, they can actually see rare events, or what's called the long tail, and see everything that's going around. You can see actually Andrew Party talk about it in this video.
Now, so far, I've talked about a lot of explicit labeling. Like I mentioned, we ask people to annotate data. This is an expensive process in time, and also with respect to, it's just an expensive process. And so these annotations, of course, can be very expensive to achieve. So what I want to talk about also is really to utilize the power of the fleet. You don't want to go through this human annotation bottleneck. You want to just stream in data and automate it automatically. And we have multiple mechanisms by which we can do this. So as one example of a project that we recently worked on is the detection of cut-ins. So you're driving down the highway, someone is on the left or on the right, and they cut in front of you into your lane. So here's a video showing the autopilot detecting that this car is intruding into our lane. Now, of course, we'd like to detect a cut-in as fast as possible. So the way we approach this problem is we don't write explicit code for, is the left blinker on, is the right blinker on, track the cuboid over time and see if it's moving horizontally. We actually use a fleet learning approach. So the way this works is we ask the fleet to please send us data whenever they see a car transition from a right lane to the center lane, or from left to center. And then what we do is we rewind time backwards, and we automatically can annotate that, hey, that car will in 1.3 seconds cut in front of you. And then we can use that for training the neural net. And so the neural net will automatically pick up on a lot of these patterns. So for example, the cars are typically yawed. They're moving this way. Maybe the blinker is on. All that stuff happens internally inside the neural net just from these examples. So we ask the fleet to automatically send us all this data. We can get 500,000 or so images, and all of these would be annotated for cut-ins, and then we trained the network. And then we took this cut-in network and we deployed it to the fleet, but we don't turn it on yet. We run it in shadow mode. And in shadow mode, the network is always making predictions. Hey, I think this vehicle is going to cut in from the way it looks. This vehicle is going to cut in. And then we look for mispredictions. So as an example, this is a clip that we had from shadow mode of the cut-in network. And it's kind of hard to see, but the network thought that the vehicle right ahead of us on the right was going to cut in. And you can sort of see that it's slightly flirting with the lane line. It's sort of encroaching a little bit. And the network got excited, and it thought that that was going to be cut in. That vehicle will actually end up in our center lane. That turns out to be incorrect, and the vehicle did not actually do that. So what we do now is we just churn the data engine. We source that ran in the shadow mode, is making predictions. It makes some false positives, and there are some false negative detections. So we got overexcited and sometimes we missed a cut-in when it actually happened. All those create a trigger that streams to us, and that gets incorporated now for free. There's no humans harmed in the process of labeling this data. Incorporated for free into our training set. We retrain the network and redeploy the shadow mode. And so we can spin this a few times, and we always look at the false positives and negatives coming from the fleet. And once we're happy with the false positive, false negative ratio, we actually flip the bit and actually let the car control to that network. And so you may have noticed, we actually shipped one of our first versions of a cut-in detector approximately, I think, 3 months ago. So if you've noticed that the car is much better at detecting cut-ins, that's fleet learning operating at scale.
With its software and hardware combined, Tesla has the best cars out there. If you like this video, click on the like button, leave your comment down below, and please subscribe.